everyone, this is lesson 4.5, Parallel and Perpendicular Lines. In today's lesson, you're going to learn how to write an equation of a parallel and perpendicular line. So that may sound intimidating, but actually it's going to be quite easy based on what you already know about how to write an equation. So for example, if you're given the slope of a line and a point, then you can find the equation by plugging it into y equals mx plus b, or you can use the point slope formula and plug it into there to write the equation of the line. So today's not much different. You only have to know the relationship between the slopes of perpendicular lines. All right, so let's look at, well actually, first of all, for a parallel line, the slopes of parallel lines are the same. So that's the first thing that you'll need to write down in your notes. So for parallel, slopes are the same. So whenever you see to write an equation of a parallel line, that means you just need to figure out what the slope of that line is, and it's going to be the same for your line. For perpendicular lines, to figure out the relationship between slopes of perpendicular lines, we're going to look at a little investigation. So let's look at this website here that compares two lines. Now, perpendicular, you probably know that perpendicular, first of all, we'll go back to our notes, means that the lines cross at a right angle. So perpendicular lines cross at right angle. And then for parallel lines, I'm going to add a little bit to our notes here. The lines never cross. So they will never intersect for parallel lines. I'm going to have to move my note here a little bit down. All right, and then parallel lines cross at a right angle. So if we take a look at this applet here, we see that these two lines cross at a right angle. And the slope of this line here, they found out using rise over run is -3/2. And the slope of this line using rise over run is up 2/3. So let's take point B and let's drag it around and see what happens. So if I drag B around, the right angle is going to stay the same, but the slopes of the lines are going to change. So here the slopes are -1 and 1. I move it up. The slopes are -3/4 and +4/3. I move it this way. The slopes are -3/5 and +5/3. So, okay, so if I keep moving it around, notice what happens. Okay, -5, +1/5. Undefined and 0. 5, -1/5. 3/2, -2/3. Oh, those are the same. How about this? 1/3, -3. 1/2, -2. Okay, so I'm dragging it around, and what do you notice that's the relationship between the slope of this line and the slope of this line? Well, first of all, they're always opposite signs. So if one is positive, the other is negative. So even if I start making this other one positive, that one's going to turn negative. And they're what we call the reciprocal, which means that you flip the fraction. So now we've discovered that the slopes of parallel lines are opposite reciprocals. Slopes are opposite, and that just means the sign. So if one is positive and one is negative, reciprocals. Right? So here's an example. My smart slate is still waking up here, so I wonder if it's working yet. All right, looks like it's still trying to wake up a little bit. There we go. All right, so here's a few examples for slope. Let's take 7/10. So if our slope is 7/10, then the perpendicular slope, I'm going to use m sub perpendicular, is going to be -10/7. If the slope of your line is -2, then the perpendicular slope will be the opposite sign, so positive, and the reciprocal of 2 is 1/2. All right, so let's look at some examples of what you would see. So write an equation of a line that is parallel to y equals 2x plus 5 and passes through the point -1, 3. So you've actually already done something like this before. So you know that the parallel lines mean that it's going to have the same slope. So the slope is going to be 2 because that's the slope of this line. Okay, but our line passes through the point -1, 3. So you have two options. You can either plug it into y equals mx plus b or use the point slope form. I'm going to plug it into y equals mx plus b. So y is 3, m is 2, x is -1. So then you have -2 plus b, add the 2 over, and you get 5 equals b. So then your equation is y equals 2x plus 5. So actually, it turned out that these were not just parallel, but these were actually the same line. All right. Okay, so here we have write an equation of a line that passes through the point 4, -5, and is perpendicular to the line y equals 2x plus 3. So if the slope of this line is 2, then the slope of the perpendicular line is going to be -1/2. And then it passes through the point 4, -5. So then I'm going to plug it into y equals mx plus b. I'm going to do -5 equals -1/2 times 4 over 1 plus b. You multiply these two. So -1/2 times 4 equals -2. Add the 2 over. -5 plus 2 is -3. So your equation is y equals -1/2 x minus 3. All right. Number 2, write an equation of a line that passes through 8, -1 and is perpendicular to this line. Well, this line is in standard form, so we're going to need to get it into slope-intercept form so we can figure out what the slope is. So we first will want to subtract the 2x over. So we get 4y equals, and write the 2x first, so -2x plus 12, and then divide everything by 4. So then we get y equals -1/2 x plus 3. So the slope of our line is -1/2, but if it's the equation of the perpendicular line, then the slope of the perpendicular line will be positive. The reciprocal of 1/2 is 2. All right, so using y equals, actually, I'm going to show, for this example, I'm going to show point slope form. So for point slope form, we would do y and then minus -1, so plus 1 equals 2, parentheses, x minus 8. All right, so you could leave it like that, or if it does say to put it into point slope intercept form, we would distribute the 2 and then subtract the 1. So we get y equals 2x minus 17. Okay, and then if you wanted, you can always graph these in Desmos or plug them into your calculator and see if they are, if they look perpendicular. Okay, Desmos might be easier to do that. But sometimes even if they don't look perpendicular, they might be. It just depends on like the spacing of your graph, if it's equal spacing with the x and the y. So don't always count on that. Okay, just I guess check your work and make sure that it's the opposite reciprocal for the slope. All right, and then determine which lines, if any, are parallel, perpendicular, or neither. So to determine that, we're going to need to find the slopes of each line. So here for line A, the slope of line A is 5. Here, I don't know what the slope of line B is because it's not in slope-intercept form. So I'm going to have to put it into slope-intercept form. So subtract the x over. So you get 5y equals -x plus 2, and divide everything by 5. So then you get y equals, remember this turns into -1/5 for the coefficient. -1/5 x, and then plus 2/5. And then here, once again, we would need to get this in slope-intercept form first. This is just not supposed to be there. So we'll add the 2x over. So you get 10y equals just 2x, because there was just a 0 there. Divide both sides by 10. So y equals 2 divided by 10 is 1/5. So 1/5 x. All right, so are there any parallel lines? No, because these slopes are not the same. So here, the slope of line B is -1/5. The slope of line C is +1/5. Right, so 5, there's no other one that has a slope of 5, so none that are parallel, so no parallel lines. How about perpendicular? So 5 would be perpendicular with negative 1/5 because it's the opposite sign and the reciprocal. So we'll say that line A, so L sub A is perpendicular to, this little symbol here means perpendicular to line B, or you can just write out is perpendicular to. Okay, so C is kind of left behind. It's not parallel or perpendicular with either because it's not the same slope. All right, so that is all for today. You won't have an exit ticket on Polaris. You'll just have, your regular practice problems in Edulastic tomorrow. So I hope you enjoyed this video. Have a great day.